So let's talk about the databases a little bit. So how much do you guys know about SQL first of all? Do you know like basic insert, update, delete, and select?
Yeah.
No? Okay, yeah? Okay. Very basic SQL. Okay. So if you don't, I mean, you don't need to know a lot. You'll see what I mean by that. So Android basically comes with a database, so it ships with a database. That's what we mean by it's a complete stack. In other words, it's it's an entire system. It's got everything that you need, including a database. And the choice of the database they made is SQLite. Okay, so SQLite is a database. It's based on SQL, like the name suggests, right? And it's the type of database that there's certain things that are kind of cool about it. So let's take a look at certain things why it's cool. So SQLite is zero configuration. What that means is there's nothing to configure about the database. As a matter of fact, you can't configure anything about that, about the database. Unlike maybe MySQL, where there's nothing you have to configure, here there's nothing you can configure, which is great. Right? It means less work. Don't need that sysadmin, right? Or dbadmin. Next, it's serverless, meaning it doesn't have a server. There's no process running. So that makes it simpler. There's no separate process that needs to run for the database, etc., etc. So it's driven by a library, right? So it's just a library that, does the job and dies. So that makes it less scalable, but makes it much simpler. But we're not talking about gazillions of gigabytes of data on a tiny little phone here. So for our purposes, it's perfect, right? It's a single database file. One database, one file. That's it, right? Straightforward. So those are sort of important things. It's cross-platform, meaning you can create your database on Windows or Mac or Ubuntu, and then you can pass it on to the phone, and it's going to work. It's the same file format. It's tiny, and it's public domain. I think this had to do a lot with the choice of the database as well. This is the license for SQLite. So as long as you agree with that, you can use it.
By saying a database, is it like a pattern or is it really a relational database?
It's a relational database, but it's stored in a file. So it's sort of similar to Microsoft Access in that sense, right? So yeah. But it is a SQL database. It is a relational database. Okay, so with that, what we're going to do is we need a database, right, to create that's going to represent our data, just like we had on a picture. So now that the service has data, right now it's just printing into the screen, big deal. But we would like to store it somewhere so that later on we can read it. Okay, so to create a database, what we need is we need a helper that's going to help us create a database and store stuff to the database, right? So we're going to create that helper, and that's going to be a separate Java class for now. Later on, we're going to sort of refactor some of that stuff. So here's what we're going to do. First of all, I'm going to close all these because I don't need them. Okay. So inside of our project, we are going to create a new file, Java class, so new Java class, okay, and it's going to be, I usually call this one DB helper, just, it's pretty straightforward, so that's the name of my class, so that's the only thing I typed so far, so DB helper.
One database that all my apps are going to share. Tomorrow I download the one that's going to call what prevention mechanisms are there? Take over that.
So all your apps share one database?
Isn't that how it is now?
So this database is going to be private to our application. So if you have many apps sharing data.
Oh no, sorry. Then I misunderstood. I thought the whole time the architecture that you showed us, you said there's one database instance and all apps just use it.
So this is the architecture of our one application. What you see here is one application.
I thought I remember from the previous one, but maybe I don't.
Yeah, no, this is Yamba.
Right. No, but generally the stack that you do for Android, I thought there was one instance for database and all the apps that you see.
Oh no, so each app is going to have its own database. Many different databases. Yeah, many different databases. Now, you may recall that I was talking about, like, for example, contacts in the context of content providers, and I said, well, it'd be kind of stupid to have a separate database of contacts for my address book, then for my email list, then for my Twitter account people, and so on. So we actually want to consolidate that data and somehow provide it platform-wide. That's where content providers come in handy. So we'll talk about that at some later point. Again, we already discussed it from theoretical standpoint. Yeah. No, it's not. So SQLite is a database. Content provider is in an interface to data. So it usually is implemented by a database, right? Remember, but sometimes it could be something else that's actually implementing the content provider. Maybe it's, going to the network. Maybe it's doing some other stuff. Yeah, we'll get to it.
So SQLite is like library like Jupyter.
Yeah, it's a library, essentially. Yes, yeah, it's a library. It's just that the framework has a built-in support for it. You're by no means limited to using SQLite. Just like I said, you guys are welcome to experiment with some modern databases. There's the whole NoSQL movement, right? So SQL kind of sucks. It's like whoever designed it back in the 60s, I don't know what they were thinking, right? They weren't thinking objects, that's for sure. So, we're kind of stuck with that. But by no means you have to use SQL or SQLite for that matter. So there are other choices. I mentioned MongoDB, I mentioned JavaDB, some object databases like that. But the one that's built in, that's supported officially by Android, is the SQLite. So that's the one that we're looking at right now. So DB helper, bam, created. So just like before, whenever you're starting something, you are going to define it as by subclassing one of the system classes. So for this one, it's going to be SQLite Open Helper. Organize imports, Control-Shift-O, and bam. And then you need to add unimplemented methods. Or in this case, it's not add unimplemented methods, but add constructor. Bam. Okay. And is there a more? And then add unimplemented methods. Phew. Okay. So just let Eclipse solve all your problems, and you're gonna get to the templates that you want in the first place, right? So this is a template, right? So just let Eclipse figure stuff out for you, and we're gonna be we're gonna be good. So subclass SQLite Open Helper, organize imports by doing Control-Shift-O, and then add constructor, and then add unimplemented methods, and you're gonna get a bunch of to-dos basically as a result of that.
Override implement methods one, and do we have to choose some methods or no? Not that.
No, I didn't explicitly go. See, to undo it. Yeah. See, in this case, I have a problem, right? I said extend over. So to extend a SQLite Open Helper, you must implement certain things because they're defined what? What are they defined as in the parent class? Abstract. So they're defined as abstract. So meaning if you want to subclass them, you must provide them. So in this case, I did here add constructor, then more add unimplemented methods. I had to do this. I had no choice over that. Now, if I want to override or implement some other stuff, which I may, then I can go source override implement methods, and it's going to give me other choices such as get readable data, get writable data, or as open, on close, blah blah blah. But those are optional, right? So you would explicitly need to go and say override if you want to override them. In this case, we don't. Okay, so do you guys hear? Okay, so it sounds like here we have a lot of work, But let's take a look at this. So what we have going on here is, let's start with the constructor. It's asking for zillion names. Context, name, factory, version. Okay? So name is going to be the database name, as in the database file name. Okay? And version is going to be a database version number. Right? But those things are pretty much constant. Right? It's not like somebody's going to... This is something that's internal to us. So we're hard coding this. This is our business, what the name of the file is, right? So what I usually do is, first of all, I do my private static final string tag, right? That's kind of what I always do, DB helper. Or if you want to do the long way, you can do the long way by saying DB helper dot class dot get simple name, right? And then I define the name and the version. So warning about this file, it's going to get a lot. We're going to end up with a lot of constants here. So don't sweat it. This file is going to be simple, but it's going to have a lot of constants. And in Java, to say something is a constant, you have to say 5 things. You know, like public. They could have just come up with a const keyword, but I don't know what they were smoking. So. So the next, I'll make this public for names. So public static final string db name. It's gonna be a name, and you get to pick up any name. I'll call it timeline.db just to be consistent. Okay, public static finals. Sorry, this is gonna be an int db version. DB version is the version of your database, and it's just an integer. No, it's got nothing to do with the SDK. It's just a version of a database for you, your internal version. You can put any number like 47, you know, but you know 1 is a good number to start with, right? But you can put anything you want.
Does it typically map to your app version?
No, it's not, and I'll explain how that works. It's not mapped to your app version automatically. There is a mechanism that's pretty interesting, but it's not mapped like that.
It's basically so that, let's say you change the schema, and the next time you have an update to your application, you can detect it and know whether or not you need to update the existing database or the user application without losing the data. So you to be able to manage the user
So
database.
typically when your app updates,
Well, nice. Only if you in the new update to your app, you happen to update your schema. But if you didn't change the schema in your database, even if you update your app, you don't have to do anything. You won't change your version.
right.
Yeah, that's why you send it to. It's not tied to your application version.
Yeah. So we'll talk about that in a second as well. So, okay. So now that we have those 2 constants, right? So those are the constants that ultimately I need to pass them to the super, right? So name is going to become db name, right? And version is going to become db version, right? Okay. And this thing, factory, that's optional if we're using a factory to create cursors, which we don't know much about yet, but we're not going to use a factory. So we'll just pass a null, right, for now. Okay. So all this basically makes our constructor much simpler because guess what? We don't care about these things. So just remove them.
Oh, is it another signature later?
Well, I get to make a signature whatever I want as long as I pass this. This is written in stone. I must give the parent those things, but how I'm gonna get created myself is my business. Bam. Oops. So I save that, and that is now our constructor, and we're done. So when we talked about where that stuff is stored, we said it's stored in, hold on, let me kill that. It's stored in here, right? So in data, and then share preferences, right? Your private directory, and that's where username and password and all that stuff is. Yeah. So you're going to notice that this place, like I told you yesterday when we talked about the file system, this place is one of the most important places on your file system, right? /data/data/blah, which is blah is your package name. And remember when we talked about create new project dialog, I said this package name is going to represent itself in many different contexts, but it has to do with security quite a bit. So it's important, right? Cool. So back to this. So now that we have organize input, so now that we have this, let's talk about on create. So that's our next to do. We're just basically see how we're just like filling in the blanks. We're just taking care of the to dos, right? So our next to do is going to be to create to handle on create. So here's about on create. On create is the method that is called once and only once ever for a particular user, and it's called to create a database. So this is where you're going to create the database, right? And what I mean by that is we are going to execute the SQL for creating the database. So if you look at what's passed to us, is the database is actually passed to us. And what we can do is we can execute SQL against that. But first we need to create that SQL. Okay? So it's just going to be a spaghetti of SQL tag code, right? You guys know, create, table, blah, blah, blah. So it's going to look like something like this. String SQL is string.format. I guess I can do string.format, or if it's simpler for you to understand, I could do create table space plus, by the way, so I'm going to define these as constant, so I need a table name, right? So I'm going to create public static final string table, what do you want to call it? Statuses, right? So plus table plus and so now we're going to create a bunch of like other stuff, right?
Can you tell me, like, common terms, what exactly is meant by creating a SQL?
What's that?
What exactly is meant by creating a SQL? Later in the common terms.
So SQL is a language, right? Invented by some woman back in the 60s for the Navy, I think, or something like that, right? And it was meant to be a language that's fairly close to English, and it has to do with creating data. And so it kind of flows, like when you say stuff in SQL, it kind of matches English pretty much. So one of the first things is you need to create a table where you are going to store data. So you're going to say create table statuses, and now we need to say what columns that table is going to have. That's what it is. So it's kind of creating a schema for this database. Does it make sense? So
Template kind of thing.
exactly, yeah. So
This method name is like confusing, right? It says on create. That I assume like it's when we are creating the database. Okay.
yeah. So this is, keep in mind, what we're creating is a DB helper, which is really an open DB open helper. So this is the guy that's going to help open up the database, right? So what that means is that if the database doesn't exist, it's going to create one, right? And by the way, if you're not sure what the syntax for SQL is, let's Wikipedia it. So if let's say, so this is a little bit about SQL and how so let's look for syntax create table, and that's what it looks, right? So you say create table, right? And then you say table name and then what it's got, right? Let me see if there's some more. Is this the same? Okay, so this is a good example, right? So you say create table, right? So this stuff is kind of written in stone, right? That's the syntax. Then you say the name of the table. We call our statuses. Then we open bracket, close bracket, right? So in between here, we're going to define the columns. So this one has 1, 2, 3 columns, right? Field 1, 2, 3, and we just make the certain field the primary key, right? So, and it goes by, you say name of the column, and then you say type of the column. So this is field 1, integer, field 2, varchar, field 3, date. Okay, that's the syntax. I've done this about a gazillion times. I always forget it, and just look it up. No big deal, right? Wikipedia, that's what it's for. What did people do before Wikipedia?
People before they could use search.
Yeah, exactly. I mean, how did you ask the world before you had
How
this
did
Google?
They write code when they could not install? I can't write my name. Go and look it up.
Yeah, I remember reference manuals, like little books you had on your desk. Yeah, with dog ears,
I didn't know that I could get
earmarks. Okay, so we want to now. We need to create the spaghetti. It's going to look like spaghetti because we're doing it in Java. So I should use a string.format here. Well, sure. Let me do it like that. String.format. This is more optimal, but because I'm trying to not confuse you at the same time, that's why I'm kind of reluctant. But the syntax is going to be like this: create table, open close bracket, and then I'm going to have a bunch of %s's in there, right? Sorry, %s here. So you guys know what this means. So this refers to that, right? And then I'm gonna put more like %s something, %s something, right? %s something, etc. Those are gonna be the columns. But now the question is, what columns are we gonna store in our database, right? So what do you think? Yeah, so we don't. So let's do this. Let's see what columns are available, right? So I'm gonna refer back to what do we get from Twitter status? Because remember, when we say get friends timeline, we get they call it status, right? Status is not just a piece of text, but it's a whole bunch of stuff, right? So this is what we have, right? So we know when it's created, we know the ID, we know in reply to retweet, and so I said let's ignore these three. I don't really care about them. Text and user. So how about we start with these four? We can always add, right? So created at ID, text, and user.
Why do you want ID?
That's a good question. So when you create a database, whenever you're creating a database table, one of the best practices, typically you have some unique identifier, right?
No, I agree with the DB ID. I was wondering why you want to take that ID into your DB.
Why would they want to use that? That's a great question. So, so one of the first columns is going to be ID, and the question is, why do we want to use? Why would or should we use this ID versus our own ID? Because what we could do, one of the simplest ways in database would be to put auto increment, and you let database worry about IDs, and starts at 1, 2, 3, 4, and so on, keeps going forever. So we could do that, and that would be perfectly fine. However, the way I see it is somebody is already managing the uniqueness of this. Why would we now have our own uniqueness?
Well,
It's
I don't know.
Sorry, quick question.
yeah.
So, do you have in mind where you're gonna do updates
Thank you.
to the database? Meaning, we're not gonna always wipe. It's
Yeah.
gonna be incremental, right? So you can use those IDs as unique, you know? Because if you see the same ID coming in, just ignore it, right?
Exactly, and that makes it easier from the updates point of view. Yes.
Exactly.
Yeah, yeah. And so the way I see it is, if there is something already, unique, why would I manage my own uniqueness? It's kind of like, if you have a list of employees, you can create a new employee ID, or you can just use their social security number, because if they're employed, they must have one, so might as well reuse the same one that somebody else is managing. Questionably managing, but whatever. Aren't they starting to recycle social security numbers from dead people? No, seriously, we're running out. Yeah, I mean, think about it. You only have 900 million or a billion, right? But there's also the encoding scheme, so not every number is actually a valid number. So and the 300,000 living, 300 million living Americans. So it's really quick to yeah. I mean, only 3 generations and you're out of numbers, or even sooner, about 2 generations, right? So it's a problem.
Change the encoding scheme. Change the encoding scheme.
Yeah, yeah.
A lot of trouble.
Lots of trouble. Yeah. What's more politically correct? Add a number or like recycle, dead people's social security numbers? I don't know.
I think they are already doing it because one of my friends, he works in HR, he told that when they got 2 similar numbers and they figured out that was ex-employee, like ex-employee's father actually. Somehow his number was in the system and for some other employee's kid had that new number.
Yeah.
Same, so like entire system crashed or something like that happened. Really, it happened because that entire key was based on that number
Yeah.
and it crashed.
Yeah, but that's actually a good idea. Maybe we could have like our parents like pass on the social security number to us.
Grandparents, yeah.
Yeah, we could get it from they don't need it anymore,
Especially if they're rich.
and especially if they don't need the pension anyways, right? So yeah, just take that number, and your pension and your retirement checks. That'd be nice. Okay, so we're gonna go with ID created at text and user, and we'll keep this simple. We'll make this integer string in string, right? We can't. So this is a Java date. We can't really store it as a date, right? Because the database, the world of objects, and one simple thing is to store this as a timestamp, which is a string, or integer, right? Well, long technically. So, okay, so let's do that. So back to this. So 4 columns, 1, 2, 3. So 4% s. So the first one is gonna be int. So the first one is gonna be, and here's what I'm gonna do. I'm gonna define the column names as constant, static, final, string. I'll prefix them with C. So CID is gonna be name of the ID column. Okay. Now, granted, we could call it whatever the heck we want. We could call it ID, underscore ID, uppercase ID, and all that. But there is something special about the ID that is used elsewhere in some systems, parts of Android. So it's actually underscore ID is what we should be using. Or if you're not sure, you can actually use the constant base columns dot ID if you're not sure what that is. Okay, so it's kind of like ID is sort of an exception. There's something special about that name. So if you, for other purposes, want to implicitly use it, we're gonna just call for our ID. We're gonna give it the same name as the system would call it, so that we don't mess things up. Okay, I'll just put a note, special. Okay, for ID. For the other ones, it's going to be pretty standard, static, final, string, column, created at, and we can just call it whatever they call it here, created at. Oh, there's so much typing. Public, static, final, string, column, user, and it's going to be user, and public, static, final, string, column, and what do they call it? Text. Now, there's also something special about this, because I wanted to kind of use the same names as they use in the object, right? So, I try to be consistent whenever I can be consistent, because at some point you're going to get rewarded by some frameworks for consistency. That's not quite the case yet. And it's also kind of hard to be consistent here when they choose a name of a column text, right? Because text is a reserved word in SQL. So I actually cannot possibly call my column text.
Some databases user is on.
Yeah, user as well. So I'm going to call this one txt, Yeah, we could prefix them with something. Yeah, it doesn't really matter. If you want we can call it Yamba created that, Yamba user and Yamba text. It doesn't really matter, because it's going to be internal to us, right? So that's why I'm kind of outsourcing the actual ugly name to this constant, right? Well, I can even spell it out, Yamba, so that we don't have that collision, and that collision is also dependent on certain. Yeah, the word. Yeah, So this is system already defines something called ID, and while this would be fine, I could just say Yamba ID, right? That would be fine. That would just work fine. It's just that in some later stages, that field called ID is actually used internally by Android framework. So might as well, take care of that right now, right? So that's why, as opposed to going with Yamba ID, I suggested we go with just underscore ID, which is what it is. Or to be even more explicit, in case somebody's reading our code, I would just actually use the system-defined property, which is underscore ID, like that. So then my spaghetti becomes, so this is going to be column ID, column created at, column user, column text. Okay, so and then let me reformat that. Okay, so you can fit in the screen. So that's %s refers to integer, second refers to int as well, and then text, and then text. There we go. So again, I apologize for spaghettiness of this thing. If you're done with this, something to think about, what would be an alternative way of defining this spaghetti string?
In the strings var, string vector.
Yeah, so an alternative to this, you guys don't have to do this, but just to kind of provide you with an alternative. An alternative would be to define it in strings XML, right? And I could just simply say like this. This is much cleaner, right? I could do string SQL, and I would just type it create table, which ultimately is going to be create table statuses, right? And then it's going to be underscore ID int comma Yamba underscore created at int comma Yamba underscore user text and Yamba underscore text, right? And actually one thing that I forgot is to make this one primary key, right? But now I save this, so now I have that SQL more elegantly defined here, right? Now the question would be, and let me, by the way, add primary key here as well, because that's primary key, and reformat it so it fits. Okay, but if I wanted the alternative way, how would they get now that string? Right, so but get, if I do get res, it doesn't exist. So where do I get the string from?
Context.
Right, so it's this context that, so keep in mind, DB helper is not a main building block. As such, it does not necessarily have context like we took for granted in service and activity. So if I needed that context around, what I would need to do is I would need to basically define it. So context. Again, you don't really have to do this, just this is more informative. But then I will say this.context equals context. First, so I save it, because we are getting it via the constructor, right? And then I could say alternatively, SQL is going to be context.getString for r.string.SQL. Okay, that would be an alternative, and I'm going to comment that out just as an alternative, right? So just so you know. But the benefit of this approach is that we get to use our constants, so that way I avoid accidentally like forgetting to put Yamba here for created that or something like that. When I define it like this, I don't really have checks and balances. So that's sort of the downside. Let me put that Yamba back. Where's the SQL? Oops, EX. Should have not done that. Okay. Okay, table statuses. Integer int primary key, comma, number. What's that?
Didn't you just create it there?
Yeah, I did, but I Control-Z'd it, and it actually removed the whole thing because it's a little retarded the actual tool. So user text and Yamba text. Okay, I'll just save it just for reference, but that's it. All right, back to this. So now, does everyone have this SQL one way or the other? Okay, chances are you're gonna get it wrong. So what I like to do is I like to log it. I like to print it out. So tag, comma, on create SQL is. And what I mean by you're gonna get it wrong, it is a spaghetti code, so it's easy to mess something up here. So might as well just print it so you can see what that generated. And keep in mind that, but once you get it right, you got it right. So this only executes once, right?
You are not creating
Yeah, I'm not executing it yet. Yes, we're not done. So now that we have the SQL, I actually need to execute it. And we already have the database given to us. So we're going to do db.exec SQL. And now we're done.
No return values for the method.
Well, it doesn't return anything.
No, the db.exec is.
Oh, does DB, does it return something? It returns void, so it doesn't return anything. Yeah.
So what if it's not initialized?
What if it fails or dies or?
Too bad.
Yeah, well,
Catch exceptions.
yeah, throws in SQL exception. So yes, we could catch it, but even if you don't catch it, it's just gonna crap out on the logcat, and we're gonna see an exception. And keep in mind, this doesn't depend on any user input. So I'm gonna mess it up first time, second time. Who cares? But once I get it right, I got it right for good. So it's not really a big deal. So far so good. Okay, so now that we have that, let me talk about a little bit about on upgrade. So on SQL, on create is going to get called once and only once when the user first time installs the application. Install first time. Well, runs the application. Run. Yeah, okay. It runs the application. So keep in mind, you do not ship a database file. One of the things I mentioned maybe as a benefit is that it's a cross-platform file. You can create it on your Windows, but that really doesn't matter. because you're not shipping a file. Database file is not part of APK. Remember? It doesn't go there. So anything that you want to pre-populate your database with, it would go into onCreate. So this actually may be, right now I'm assuming that we are starting with a blank database. But maybe you're not starting with a blank database. One of my favorite apps is Calorie Counter. Like, you guys know it? Like, it's you can like scan a barcode of what you're eating, and it automatically figures out calories and adds it and all that. And if I'm at McDonald's, I can like quickly check on a quarter pounder with cheese and see how many calories I'm about to commit to, right, and so forth. So it partially goes online and gets the data, but it also seems to work really fast. So I would assume that some of the common stuff, like how many calories in an egg or a slice of bread, well, it's probably pre-populated. So let's kind of like talk about that like a little bit. Why database in a mobile app? Like why are we having a database in a mobile app? Speed. Yeah. So So I mean, ideally, these are tiny little devices, right? I mean, these are things that you can lose, damage, lose, and so on, right? So we do not want to store a lot of sensitive data here. In a sense of sensitive, in a sense of like I'll miss it if it's gone, right? I'd rather keep the data where it belongs, in the cloud. Like the cloud is a safer place. Okay, let's assume a cloud is a safe place, right? So we want to keep it in a cloud, right? So, but this is much faster access. So it's kind of like you may start with some data here, and then over time, we're basically just loading more data into it, and so on, right? That's sort of what's going to happen. So essentially, this is a cache of the cloud, eventually approaching cloud, right? So just like my little calorie counter, over time learns more about those common food like chocolate and beer and things like that. It's common food, how much calories it's got. So in the future, it just runs faster and faster and faster, ideally, right?
Does Google limit the storage capacity from that?
There's a limit. I don't know what it is. The whole data partition has a limit, and that's why the whole movement to move the apps to the SD card was there, and that's why Froyo finally got it. So
what does that mean again? If you're moving your apps to SD card, means what?
yeah, there's a way. You remember how I said user apps go into /data/app? Well, that may not work for some people. So there's a way to push those apps into SD card, because people who are downloading hundreds of apps, or an app that contains like a library that contains 10 megabytes of say DRM software or something, right? So suddenly you need to you're running out of the user disk space.
So the whole app itself is on the
Yeah.
Just the data of the app.
No, the whole app, and that's why you see the folders I keep ignoring are these folders, the secure folders and so on. But that's basically a way to move the data to those folders, apps, and system is supposed to do that automatically now in Froyo. But there are hacks to do how to do it before that, because you can't run before Froyo. You weren't able to run apps off of the SD card. So on one hand you're running out of space, on the other hand you have a ton of space, so that's what that is for. Okay, so back to this. So yes, we're shipping an empty database, a non-existing database. So this creates a database. Maybe you want to exit. Maybe you want to load up a bunch of stuff, right? So in that case, this approach may be good, because I may have like a SQL to insert, right? Like with a zillion insert records, right? To pre-populate the database, like maybe you're loading some common stuff that doesn't change that much, so it doesn't need to go online. So anyway, so I just wanted to point that out. So let's talk about the onUpgrade. So onUpgrade executes whenever the version of the database that you currently have installed and the version of the database that the system reports as is different. So in other words, when you create DB helper by saying DB helper DB version, and since we hard-coded that to 1. So if I create a database now, right, and it's etched into the database that it's a version 1, okay? If I create a database, run it again and again and again, as long as that's the same version 1, it's going to be the same version, okay? So if I change the version, the database is going to get recreated. So typically what you would do here is you would gracefully upgrade from older version to new version. So old version for a user, so the version, again, version of a database, as like we said earlier, is not related to the version of application. So let me give you an example. I release version 1 of my database, of my app. It's got database version 1. I release version 2. I release version 3. I release version 4. But I haven't changed my database. Now in version 5, I want to add something new. I want to add like location where the tweet was tweeted from, right? So now in version 5, my database is at version 2, right? And then in version 6, my database is, maybe I added something else, like, you know, support for retweets. So now I'm at version 3. Well, some users may move from version 1 to version 6. It doesn't mean that they moved, you know. So in other words, you got to provide a way to upgrade from all the older versions to newer version, right? You can, that could look different ways. You could basically, you know, you could say, you know, you could have, for example, if old version, don't do this, version is, you know, 1, you know, whatever, do something, and then you can increment, you can say on this dot on upgrade, right, and then do it on db old plus old version, right, new version, right. So you could do it recursively like that, or you could provide a bunch of if-else statements and then do something. Could be, for example, this statement. So for example, you may have a bunch of alter statements, db.exec, right, SQL, right? So you could have now a bunch of, so maybe this is a SQL 1, SQL 2, SQL 2, and so on, right? Like for example, we have a web app, and our web app has 138, I think, versions of SQL, because that's how many times we changed it. And it just
Learning Android, you have a web app?
no, for Maracana, for different project. It's a Java project, but still, the idea is like schemas change, right? So you know, you can see how, you know, you could have zillion versions of schema, and typically this would be a bunch of alter tables. So it's not like you don't want to destroy a database, because what if a user has been using your version 2 of the app for like years, has a ton of records, right? And now there's a new release, and you just wipe out the user's data. That would be, you would piss off some users really bad, right? You don't want to do that. So you'd rather alter table, which means add the columns but preserve the data. And, you know, you guys can look up the whole alter table. That's how it works. You can, for example, alter table add, and you can add something new, and that just adds a new column, right? Preserves your data. That's what you would typically do. However, since we are just doing development and we don't care about that right now, we don't have a second version. So for development purposes, what I would do is I would just blow up users database. So I would say exec SQL drop table if, I think it's drop table if exists. Drop table if, doesn't say drop table if exists, and then table. So, and then I would run this dot on create, right? So I would just run on create. This is just quick and dirty, you know, I blow up the database and recreate it, okay?
So you have the ability to call on create yourself?
Sure, but you gotta pass it the database object, yeah. No. And as a matter of fact, what I'm going to do is I'm going to log here, log D, just to kind of show you what's happening. Tag, comma, on upgrade, dropped table. So far, so good. So now that we have we have a DB helper, we have a way to create a table, we have a way to drop a table, right? So where do you think we are gonna use this DB helper from? Let's take a look at the picture.
Yeah, service.
Right, so it's this guy that needs to do that, right? So service. So if I look at my service, update our service, and remember, this is where we have the data. Right now we're just printing it to the logcat, right? But what if we wanted to do one better? We wanted to actually open up a database, write to a database, and close the database, right? So I could do, I'm gonna just do it here. I'll say open database, right? So I need to create a DB helper. Now this is not going to be optimal code, right? I'm just going to doing it so it fits on the screen, and then later on we're going to refactor this, right? So I'm going to create my DB helper. So DB helper is new DB helper, and I need to pass it the context. The context is going to be updater service.this, because updater service is a context, right? Yeah, updater service is a, meaning somewhere along it's a child of context, right? And what the way you would find that out is by saying service, and this, and see how there's a lineage that you can see. Yeah, it's there, and see somewhere along the way it is a context, right? So now that was easy. We just created that guy, and that's gonna create this guy, and that's gonna internally do some logic to invoke on create as needed, on create or on update. I just did it. You know, as I said, this is quick and dirty. We're gonna optimize this later on, but this is a place I just did it for now. Okay. So now that we have that, once you have the DB helper, you can actually get a database. So it looks like this: SQLite database DB, and you just say DB helper, and then you either do get readable or get writable database. Okay. So which one do you think we're gonna need? Yeah, because in this case we're doing an insert, right? So we're gonna get a writable database, organize imports to get that. And you know, the opposite of this open would be DB close, like close database. So DB dot close and DB helper close. that would be just a nice thing. So basically, I'm closing what I'm opening, and I'm closing what I'm opening, right? Again,
Open and close every 5 seconds.
yeah, not optimal at all. I want this just to fit in my screen right now. Yes, we're gonna refactor this. Yes, good point. But we will be opening and closing quite quickly, quite often actually. So far so good? Okay, so what I want to do is I want to show you how this works. I just wanted to demonstrate a couple of things. So if I do, where's my ADB logcat running? It's right there. So what I'm going to do is I'm going to run this. I'm installing Yamba. Okay. So to kick started, I need to start a service, right? So menu, start service. Okay. So here on create. So let me see. On created. So on created, on started service. On running, right? So it's running. So then what it's doing is on create. So there's my DB helper. On create table statuses, blah blah blah, right? So and it executed once, right? So in 60 seconds, it's going to execute second time, and let's see what happens. I think I left it at 60 seconds, right? And this is the list of 20 most recent posts from my friends in the last 20 hours, right? 24 hours. So we have to wait an entire minute. While we're waiting for that, what I would like you to think is, where did this database get created? Data, and then, okay, it's running. Okay, so running, update running. Aha, this time around there's no create database, right? Okay, so I'm gonna stop my service at this point, right? So it's all stopped and all that, right? So we see that on created ran once. I told you it's never going to run again, right? As a matter of fact, here I can I can restart the whole thing, and let me change a line of code, save it, recompile it, right? Do a run, which republishes it, reinstalls it. Okay, does all that mumbo jumbo. Apple K to clean this. Clean. Okay. So no, still not running. Started. Okay. So menu, start service, and see, you don't see it. You're not gonna see it. There was no on create. Right. So never ever will on create ever run again if it worked successfully.
Because the table exists?
Yes, because the table exists. So now let's take a look at that. Okay. So now that we have the database, and you guys said that the database in /data/my package, so com Maracana Yamba, right? ls. There's a new folder called databases, which we haven't seen before, right? cd databases ls. And there's a new file called timeline.db, right? Make sense? So what I can do now is I can actually see what's inside of this file. So the good people who created the shell also luckily included the SQLite DB tool on the shell itself. They didn't include a lot of other things like grep, vi, and other tools that you would need, but they did include SQLite 3. So what I can do is I can use SQLite 3 to connect to this database. Okay. So for those of you who are new to database, let me show you what I mean by that, so don't get confused about it. So SQLite, so if I do SQLite 3 timeline.db space, okay, I am now inside of a database. When you see a prompt like this, that means you're talking to the database. When you see a prompt like this, that means you're talking to my device. When you see a prompt like this, that means you're talking to my Mac. Okay, different languages altogether, same terminal. So don't get confused about that. So I'm speaking SQL now. Well, you can speak two languages in this prompt. One is SQL, one is SQLite 3. So SQL is the standard SQL language, right? I can do stuff. But SQLite 3 is specific to SQLite 3 database. If you're not sure what you can do in SQLite 3, you can type .help. As a matter of fact, all the SQLite, there's no, it's just .help. All the SQLite 3 commands start with dot. So blah, right? So if you try to get out of this, it's quit. Right? If you want to know what the schema of this is, you say .schema, bam, and you can see that there's our database indeed successfully created. Right?
So regular SQL stuff also works. I can say describe table.
Yes, you can do. You can say select star from statuses, and you're gonna get nothing, right? Yeah, you can do describe, but describe table is not a regular SQL. That's a MySQL. So that's a different SQL. So SQL has so many dialects. So to connect to your database, like if you want to check what's in the database, I mean you can go and create all this crazy application to do that, but that's going to take you a long time. If you just want to dig deep into the database to see what's inside, right? Verify that things worked. So far so good. Okay, so that's something that I want to show you. Here's a couple of things I know you guys are gonna struggle with because it always happens. You may be typing select star from statuses, and then it's like doing this, and you're like, okay, .quit. I told you .quit. It's not listening. Okay, and it's now in this infinite loop. Why? Yes, when you start a SQL command, it's not going to stop until it sees the semicolon. Okay, so you got to do semicolon. Okay, and then you can do .quit and you're out. Okay, right? You're going to try to do dot schema here on a command line, and it's this is now Linux, and it's going to say I don't know what you're talking about, right? And so, and the third final common problem is that you may be in a wrong folder altogether. So, for example, if I'm just one folder up, I'm now in SQL in here, right? And if I say SQLite 3, and you may be doing, oops, this doesn't work. It's SQLite 3 timeline.db. There's no error. There's no problem. It's successfully connected to SQLite 3. However, it created a brand new SQLite 3. And now you'll be .schema, and you're like, what the hell? There's nothing in my database. Why is it not working? And then you're going and you're now, spending your brain cycles debugging Java, whereas you're looking at the wrong place in a file system altogether.
What did it actually do? Why would it create a new database?
Because if it doesn't have a database, it thinks that you're trying to create a new one. That's how it works. So be mindful of that. So I'm gonna be quitting out of here. That you gotta point it to a right file. I guess the safest thing in the world would be to say SQLite 3 and then type the whole thing: data, com, Maracana, Yamba, databases, timeline.db. Okay, .schema. Oops, schema. Oh, that even works. I guess you don't have to finish the word schema. So, but that's kind of be mindful of that. Yeah. So you had a question.
Yeah. Are you allowed to actually see other application databases, or
Good question. So, are you allowed to see other application databases?
because some people could have proprietary stuff?
Yeah. If I have a rooted device, which I do on the emulator, yes. So, want to poke around other people's databases? Let's see. What do we have? So I'm gonna .quit. Oops, .quit. CD back. PLS. Ooh, look, all these private package names. Remember we said all the private package names are here. Let's see. Let's see. You wanna see, for example. Do you want to see settings, system settings, right? There it is, COM Android settings. So I'm going to go CD, COM Android settings, LS, but there's no database. What the heck? What's the secret here? Huh?
See it.
What?
You can see it.
You can see it, but there's no database. Wait a minute, so where does settings store its data? Didn't we talk about that?
It's not the data. Maybe some other place data.
Remember I showed you on day one, I talked about content providers, and I said we in the system we split it, we decouple the app that controls the data from the app that controls the UI. So the one that I'm looking at right now is the app that controls the UI. It's the UI app. Similarly from contacts, there's the contacts app, then there's the contacts content provider. So if I go back to this list, you may notice that there is actually COM Android providers settings. So now if I go there, LS, look, database. Ooh, this smells good. LS, settings.db, SQLite 3, star, okay, dot schema. That's where the system data is stored. And now you can do .dump if you want to just dump all the data. Bam. That's all the data that is in there. So these are all the stuff like these are the lock sound, unlock sound, car unlock sound, dock, emergency phone number, screen time off.
There's no way to password protect this.
Well, this is a rooted device, so I'm a root and I can poke around the file system as much as I want. On an off-the-shelf device, you can't do that.
No, I'm thinking, like as a developer, you create the super game, right? You put it on, you send it to the market, people get it. Then there's this guy or two, they root the device, they get all the data out of it, they put it on, on the internet. Then you
Yes.
lost your data.
Yes, so yes, they could look at your data. That's correct. So user data on user device is not secure. So that's why you would you would either encrypt it, right, or you would store it online or something. It's no different than if you download a game for a PC and you're playing it, and then later on you want to hack its data. It's somewhere stored right on the PC. Right? So it's no different in that sense. So I said this is never going to happen. This is never the on create. So I'm going to .quit this and clean this. I'm going to cd into our package. So com cd pwd. So cd com maracan and then what's that?
Doesn't auto-complete.
It doesn't, because they were the version of Bash that they gave, or SH they gave us, is like that. But you can replace it with a busy box, and then you can have more shells. Yeah, it's kind of annoying. Okay, so as I said, what if I wanted to now change my database, right? Right, so obviously changing the software doesn't change the database. So what I could do is I could just jack up the version number. So I could go 2, or 47. It doesn't matter, right? As long as that number is different. If I go 2, for example, right? So now the system, next time it tries to open a database, it's going to say, look, the database I'm opening is at version 1. It does exist, but it's at version 1. The new one is at version 2. So instead of using on create, it's going to call on upgrade to upgrade the database. Right? So you can kind of see that. We're going to see it by this should be printed out, right? So if I run it, Yeah, I'll take a look in a second. So if I click on this, okay. So so let's take a look. On created, on up running. Okay, on update dropped table statuses, and then reran on create. So that's kind of how you can trigger on upgrade on for other users. Now, as I said, typically, let me stop my service so I don't annoy my online service. But as I said, typically you would do, typically you do alter table here, right? So that's typically what you would do to gracefully upgrade the database schema. Yes. So that's basically that. So questions, comments on database?
So when will on upgrade be called?
On upgrade is going to be called whenever whatever is in the code version of your database is different than what's on the file system that the user has.
So when you push a new APK with a different version.
Exactly. When you push a new APK and you as a developer hard code that number, because there's no reason for that ever to be self-coded, right? It's you tightly control your schema, right? It's internal to your app. So whenever that changes, then the system detects whatever the database on the file system is different schema version than the one that your software requires. Then it runs on upgrade, and that's where the opportunity to upgrade the database.
Are you sure that drop table exists syntax again and there is a print exception with that?
Print your exception. If it's a SQL exception, it's something's wrong with the SQL.
It says print an exception.
It says right there. The answer is right there in the exception. Yeah, look at the logcat, right? I mean, yeah. Okay, let me take a look. And in the meantime, you guys think about how we're going to insert data into the database. So the next question is, how do we now have the database. We have the database connection here. How do we take the data and then put it into this place right here? Right. So in this case, what we did is we created. Let's look at it this way. We created a spaghetti SQL and we ran exec SQL, right? Is everyone good on that? You guys stuck on something else, or should you need more time? Everything good? You have any?
I have some problem, but maybe.
Okay, so yeah, so let's do this. Let's finish. This is the last little piece. Let's finish this, and then I'll help you guys with your individual issues. So, you guys know now how to create a piece of SQL, run it, and we saw that works. Woohoo! So when I ask a question, how do you insert it in a database? You could simply say, look, we have the data here. We could now create a SQL, so I could do another, whatever, string SQL, and then create some kind of, don't do this, insert into statuses, blah, 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 right? I could create it here and then run my db.exec SQL and be done, right? But there are lots of things that are wrong with this approach. For one, we would have to create more spaghetti code, which we dislike, right? Secondly, tell me, what are other issues with doing stuff like this? And one is from performance point of view, the other one is from security point of view.
SQL injection.
So SQL injection is it's the security 101 issue, right? Everyone knows what SQL injection is? No? So, SQL injection is basically if you have a piece of something like this, and you're gonna have your insert into SQL, and you're gonna have your parameters. Well, when I ask you to type in a status, who is to say that you're gonna enter the real status? Maybe you're gonna enter something else that's sneaky. That's gonna once I'm gonna put it into my desk. What if what you entered? So I'm expecting you to enter something here, dot dot dot, right? But what you entered is something like this. Drop table statuses. What if you enter something like this as a status? You just delete my data. See? That is a SQL injection 101. Okay? What is the second thing that's bad about doing this approach?
Appending to the same string tag, string as string, not using a string buffer.
Yeah. So that I'm not using a string buffer. Sure, I could. This is the Java performance thing. I should use a string buffer if I'm doing a piecemealing a string. But what's another? And you're on the right track. You're talking from a performance standpoint. But what's the other issue with the performance here? This would need to be then parsed every single time. And that, if you're doing that in a loop, that becomes sort of a big deal performance-wise, right? We're cranking this all the time. So that's bad, okay? But if I'm saying that's bad, why didn't I say that's bad here? I mean, aren't we doing the very same thing? Okay, so I'm doing it only once ever, so who cares about performance, right? Once ever, right? And secondly, there's no user input, so who cares about security, because there's no opportunity to mess this up. It's nothing here is dependent on a user. It's all hard-coded, right? So that's why. That's why this is perfectly fine, and that's why this is perfectly not fine. Right? So we're not going to do it like this. What we're going to do is we're going to create a values that we're going to insert into the database as something called content values. And what content values is a data structure that is basically name-value pairs. Everyone knows name-value pairs, right? It's pretty straightforward. So I'll show you what we're going to do. So we're going to create a should do this outside of a loop, but in interest of fitting on the screen, I'll just do it here. Content values is new content values. Okay. Organize imports. And what content values is simply mapping from one value, from database name to a value, to the actual values. So values dot put, and you just have a bunch of puts. So the key is going to be our database key. So db helper dot id, and the value is going to be the value that comes from statuses, right? So status dot id. That's easy. So values dot put db helper dot column created that is gonna be status dot created that, but since that's a string, I need to get it converted to a I think it's get time, right? Get time to convert it to a long, right? Values dot put db helper dot user, status dot user dot name, right? And values dot put db helper dot text with status dot text. So we create values, create content values, and once we have the content values, we simply need to insert it okay, And what we're using to insert now is we're using we are using something called a prepared statement. So it's going to look like this: db.insert, right? Okay, and we're going to say table. So the table is easy. It's db helper.table because we have that as a constant. Now column hack is that. It's a hack. You know, it's don't worry about it too much. It's null, and values becomes values. Right?
What is the second argument for it?
So the second argument is a null column hack. So let's take a look. So look at SQLite database, and let's take a look at those functions. There's because we're going to look at something else as well in a second. But there's insert in there. So let's take a look at insert. So takes table, which is a constant, right? We have a table constant. Now column hack and values. So table is a table to insert. Null column hack, SQL doesn't allow inserting a completely empty row. So if initial value is empty, this column will explicitly be assigned a null value, right? So that's what we are doing. So if initial column is empty, that's why it needs to be something. So that's why we're going to put a null in here, and then this maps the initial values to the rows, right? Yeah, don't worry about it. You're just basically going to pass null.
Always or the first time?
Well, if you wanted something else for a completely empty column, then you can put something else.
Row, no. I understand empty column, right?
Empty row, yeah.
Why would you ever want to say
Hmm?
it's okay.
So, so let's take a look at. Remember, I did a dump recently. What was the dump? I deleted it. Yeah. So again, what I normally would have had is I would have something like this: insert into statuses, and then I would have ID. Sorry, underscore ID, but created that, but user, but text, right? And then I would have values, and then in values I would have a number here, like some number ID, right? Created that would again be some kind of number. User would be, I don't know, Marco, and text would be hello from San Jose, right? That's what it would normally have looked at if I was creating a something like this by hand, right? So essentially what I'm doing is I'm mapping values to column names, right? Values to column names, right? Values to column names, right? And then values to column names, right? So that's what this is here, create content values, right? It's simply mapping values to column names. So this is a column name, this is the value that goes into it. Got it? That's what this structure represents, right? And then insert takes that structure and intelligently creates this piece of text for us. That's all it does. It's not really doing a lot of magic there.
So how is this faster than?
So it's faster because it pre-compiles it. So it doesn't need to parse this statement.
That statement is really long.
Yeah, And you do it a lot, especially inserts. You may be doing thousands of inserts sometimes, right? It depends on, but this is a precompiled statement, so that makes it faster. And since it's precompiled, it knows that it can only have one specific value here, that it must be integer, and it cannot have semicolons and quotes, which are the scary things. Like the quote is the scary thing because that escapes. That's the escape character. So it can do some kind of validation like that. It's like, hey, I'm expecting a number here. This better be just a number. If you're trying to sneak in some SQL in here, I'll freak out. That's what it does.
So this completely prevents injection.
Exactly. You are 100% safe from injection when you do prepared statements. That's the goal. Yeah.
If I don't put the C user into the various component, just part of that one.
So if you don't put it, it's just going to have it empty. It's as if you it's going to behave the same way as if you didn't put it here manually. So whatever. Well, it depends on how your table is created. So for example, if I had not null be a constraint on a database,
So it's primary key.
well, yeah, so that is a constraint. So in this case, if I don't provide this, that would be a constraint. But that brings another point to the table. So if I run this, let me run this, and I want to see what happens. Am I in my database directory? I am. So I'm gonna do SQLite 3 star, SQLite 3 star, and dot dump just to see what's in the database. Okay, so I have pretty much empty database right now. You guys can verify that, right? Now let's do. Well, kind of lost. Okay, this is what I was looking for. Okay, delete it. So what I'm gonna do now is I'm gonna run my code. So menu, start service, bam. Okay, getting data, boom, ran. Okay, I'm gonna stop it so I don't have a lot of confusion there. Okay, stop it. And so now I'm gonna go and do dot dump again. Right? So we did dot dump just seconds ago, oops, like right here, right? Do dot dump, bam. Look, all the data is in the database. These are the equivalent of statements that I would have to do to recreate my database. That's what an insert statement looks like, right? Yeah? Make sense? For those of you who are new to SQL, that's what, let's say, insert statement looks like. So see, kind of flow, insert into statuses, values, blah, blah, blah. It's kind of like in English.
I didn't quite get the point where you said it was precompiled with.
It optimizes it. So as opposed to
What
having
exactly is precompiled with?
the statement itself. So as opposed to having to every single time parse insert space into column, you know, there's a cost to that. It knows, hey, this is an insert statement, right?
So does it have to parse it every time? Or-
Doesn't have to parse it. It's prepared. It's what's called a prepared statement. It's much faster because it knows what it's doing. It doesn't have to every single time try to reanalyze your English sentence. Yeah. It knows it's doing insert. That's all it's capable of. Yeah. So now that we know that this now I can also do regular select star from status is semicolon, bam, and here's the data. So the data is there in the database.
I get an error in sending it works for a couple of entries, and then after that, I keep getting the
Awesome, great.
error in sending
Woohoo! Cool. So everyone happy with this so far? You're tiny step ahead. So is everyone happy with this so far? Okay. So this worked great, right? First time, everything's nice and clean. Let me run it second time. Watch. Start service again. Running. Wow, crapping out. Exactly. So I'm going to stop it because it's going to keep doing that. So let's take a look at all these. So I have zillion and one exception, right? That's the bad news. The good news is they're all the same, so you can just treat them as the same reason, right? So let's take a look at this exception. What does this say? Constraint exception. Constraint failed. Okay. So it says constraint fail, and it says comma arcana update 91. Okay. So I go flip to that page, 91. So here it's failing with an exception called constraint fail. So you pointed out the reason why it's failing is because we said ID is primary key, but then we're trying to reinsert something with over and over again. Because keep in mind, what we do, get friends timeline returns 20 most recent updates from my friends and me in the last 24 hours. So and we're checking this every minute. So unless you have a lot of friends, which I don't, you're not going to have a lot of updates. So you're bound to have repeats. You're going to have a lot of repeats. This is partially why pull sucks compared to push. Right? We're using a pull, so we're actually wasting a lot of bandwidth and computing and cycles and all that along. But that's a different story. But anyway, we have a lot of repeats, a lot of overlap, right? So we're trying to insert it and it fails. So what do we do? But how do we, but check the ID, I would have to do, go to database, pull the data, check the ID, then... Yeah, you can just let it fail and ignore it, do nothing. That would be one solution. I could just say, there's actually something called insert, don't do this, or I could just do this, source, surround with, try catch, and call it a day.
In this case, you only have 20, elements you're trying to insert. What if you have 20,000? Then you going for 20,000 for the same answer?
Well, but in that case, I may want to check. Depends on what your cost.
Traversing 20,000 records, right?
Yeah.
So,
but either way, you're gonna take a hit, right? You're either gonna fail with try and take an exception, or for each one you're gonna be trying to go to the database
traverse the whole thing.
to check, and either way you're gonna take a big hit.
Yeah. Yeah, we're gonna improve on this. We're actually gonna memorize, since it's based on a timestamp. Everything is chronologically ordered, so we can actually at some point save the timestamp and remember what the latest record is. Yeah,
That's the last.
yeah, yeah. But I want to kind of grow it so exponentially. Piece, but so this would solve it. So I could successfully just ignore this. This would work just fine. So if I install this, run it. I'm not gonna have that problem again, and everything's gonna be fine. So let's see. So menu, start, and see it's getting tweets. It got it, nothing complained. Okay, so I just got a bunch of exceptions, did nothing about it, ignored it. So I'm gonna stop it now.
What is the way to get out of the SQLite shell?
Get out? Well, but like I said, first you need to make sure if you are in a select statement, you need to press semicolon and then dot quit. Dot quit, yeah. Or Control D, right? Control D it also works. So if you look at here in insert, there's insert that we used. There's insert or throw. This is why sometimes referring to documentation is useful. But there's also something called insert with on conflict, which provides for a conflict algorithm. So you can say what to do when there's a conflict. And this is relatively new. It's since API. Did you guys notice this? There's a see how I can filter by API level, and then it grays out stuff that doesn't exist. Yeah, so you can say what API level you're working on, right? So, but it also tells you what the API is. So here, this is available since API level 8. It says that insert with on conflict, and you can provide a conflict algorithm. The row ID of the newly inserted row or the primary ID of the existing row if the input param conflict ignore. So yeah, I can use this. I just need to know what conflict algorithms there are, and that will be conflict algorithm abort, ignore, fail, none, replace, rollback, create. There you go. So this is actually pretty cool, right? I can intelligently now say, as opposed to, so I don't care about this, I'm gonna keep it insert or, and what is it, what's the name, insert or, so hold on, insert or with conflict. Ugh. And then I need to provide a conflict algorithm, and it's going to be SQLite database dot, and then pick one of these. So abort. Now don't fail. Now ignore. So when a constraint, the row that contains the constraint value is not inserted or changed. All right, continues normally. None. Use the following when no conflict action is specified. Replace. For example, we could just replace. Maybe there's an ID is the same but something changed. I can say rollback, you know, and so on. I'll just say replace, for example. Right? Control Shift F to reformat, and that's pretty elegant now as well. Okay. And just to do a quick test that it all works. And then I do menu. Start service, bam, got all the tweets, but nothing complained, right? I'm gonna stop it, and I'm gonna just check in my database. I shouldn't have more than 20 plus records because, you know, I just want to make sure that it's not multiplying, right? So I'll say select count star from statuses. Oops. How do you?
You're not inside SQL.
Oh, thank you. I thought I'm used to this working, but it's not. SQLite 3 star, and then I'm gonna say select. Yeah, C20. It's a SQL. I mean, you can just do select star from statuses and count them if you want. But you can also do select count, and then count is a function, a SQL that gives you the number of records. So.
You said insert with on conflict, and what are the list of conflicts options that you have?
Well, you can look it up in the documentation. It's right here, right under SQL, because it's. I said replace, but you could just say ignore. So any of those, you know, if not sure, I mean, you can just put them out. You can just put you can just do a SQLite database dot, and then they're right here, and they're explained.
I think these are not portable, right?
Hmm?
It's not portable. You get locked into the SQLite database using
Yeah.
So you just can't switch to MySQL.
No. Yeah. No. But
But
it's.
aren't you already logged in?
No, your database
Oh,
logic-
because you. Oh.
Because of what?
no, your database logic should be independent of your database.
Your database logic should be independent of the database. Yeah, I mean, you are somewhat committing to. Yes, we are heavily depending on the framework API for database. Yes, so we're not by no means abstracting the database. This is really entrenched with SQLite. Yes. So it knows all this stuff, how to magically create a file, update the file, store the versions, etc. That is absolutely true. You know, so it's not a you know. So when you program for mobile, concerns are different than concerns you had with web apps. Like with web apps, I would be more concerned about concurrency. I would be more concerned about user management, right? I would be more concerned about replication, clustering, fault tolerance, that sort of stuff. Here, that's why I said, what are we using here this for? It's really a cache of some stuff online, right? So do I really care about replacing the database? Not really. It's not in the cards.
I want to use your Mongo SQL.
Yeah. I would have to rip up a bunch of stuff. So what I would do, what we're going to evolve to, is for all those good reasons, we are going to replace we're not going to do this, but we're going to do this and then this. Okay, for those reasons. So we're going to abstract the data with this guy called content provider, right? So that's going to be our goal. And then we don't really care. Maybe this is from that point on not even the database. It may be somehow going back to the cloud or something. Who knows? Yes, because then we can inject whatever business logic we want. Too good? Cool. So at this point, we have this guy working, and we have the data in the database, and we can verify that we have the data in the database. And so that brings us to that point. So just to kind of give you an idea where we're at in the grand scheme of things, that is roughly the end of chapter. We're like right here, right now. Okay. So if anybody, this is sort of what we just did in the second half today, and this is what we did in the first half today, just so you kind of have an idea where we're at. It nicely boils down to that. And then, so tomorrow we're going to do something called lists and adapters. So our next logical step is to work on this guy. And we're going to do this in 3 iterations. We're going to, or a couple of iterations. We're going to build it first like quick and dirty, then we're going to say why it's not good enough, we're going to fix it, then we're going to fix it once again, and so on. So that's sort of what we're going to do. And at that point, we'll have the fully working things. Everything else is sort of a nice to have, but it's good because we'll have a good day and a half to do a nice to haves, like broadcast receivers and some other stuff that we can plug into the mix. Make sense?